In section 3.4, we're going to review vertex form, factored form, and standard form. We're going to be pulling these equations from the graph. For vertex form, I look at my slope, it's going up by 2. My vertex is at +1, -2. My vertex form would be y equals slope x minus 1 squared with a minus 2 at the end. Factored form, I have my slope is still a 2, x-intercepts are at 0, 0, and 2, 0. For my factored form, I'll write 2 times x minus 0 times x minus 2. If you really want to, you could just write y equals 2 times x, x minus 2. I prefer the 0 because it helps me remember that I have 2 intercepts. But you could write it that way if you want. From there, I need standard form. I'm going to use factored form to build standard by distributing. When I distribute, I have to be careful there's a 2 in front on this one. So I'm going to do x times x is x squared minus 2x minus 0x negative 0 times negative 2 is positive 0. Whenever there's a 0 on it, it's going to go away. So I'm left with x squared minus 2x. Because of this 2, I need to multiply everything in this by 2. Which gives me my standard form is 2 times x squared is 2x squared. 2 times negative 2 is negative 4x. And then if you really want to keep the plus 0 on the end, 2 times 0 is still 0. So if you really want to have that there, you can. Or you can leave it without the 0. Both would be marked as correct. Question 2, slope is going down 2. My vertex is at 4, -4. Y equals my slope, x minus 4 squared minus 4 on the outside. My slope is still going down by 2. My x-intercepts, it does not exist. They don't touch the x-intercepts, so I'm going to skip this. Later on, you will learn why they're called imaginary solutions. So you'll learn how to find them later algebraically. Because I do not have factored form to build standard, I'm going to use vertex form. And this is going to be one that's a little bit difficult. So I have a -2. I'm going to write x minus 4 twice because it's squared. This minus 4 is hanging off to the edge. The 2 does not get multiplied by the 4 over here. I'm then going to distribute it. X times x is x squared minus 4x minus another 4x plus 4 times 4 is 16. Then when I combine them, I get -4 and 4 make -8, x plus 16. I cannot add this on yet. This is still hanging out, and this is still hanging out. I need to now double my expression that I just distributed. That will make it a 2x squared minus 8 times 2 is 16x plus 16 times 2 is 32. I then check my signs. It was multiplied by a -2, so that'll make it negative. Negative times a negative makes a plus. Positive times a negative makes it a negative. And then after that, I have a -4 attached. So my final standard form is -2x squared plus 16x minus 32, and -4 make -36. Slope form, slope, down 1, vertex, -4, up 3. Vertex form would be y equals -1, x plus 4, squared plus 3. Slope for factored form still -1. My values are decimals. If you want to, you can use your graphing calculator to find them, to then factor. These would be called irrational solutions, or they'll be decimals. We are going to skip whenever they're decimals. Later on, you will learn again how to find the x-intercepts algebraically when you can't visually see them on the graph. For standard form, I'm going to use vertex to simplify. I have -1, I write x plus 4 twice, and I have a plus 3 on the end. I'm going to leave these for the end. I get an x squared plus 4x plus 4x plus 4 times 4 is 16. 4 plus 4 combines make 8x plus that 16. My -1 will just multiply through and change all of my signs. And then I will add that 3 on. So I'm left with -x squared minus 8x, 16, 15, 14, 13. If you want to use your decimals calculator to fill in factored form with the decimals, you're more than welcome to use your decimals calculator. You would just enter in one of the equations you've built, and it should match up to your graph. All right, I'm going to convert the expression x squared plus 3x minus 4 I'm going to use my Desmos calculator. I'm going to use Desmos graphing. Okay, so my notes say x squared plus 3x minus 4. X squared plus 3x minus 4. It gives me my intercepts at -4, 0, and if you highlight over it, it'll tell you the point, so 1, 0. Then my vertex, I'm going to highlight over my vertex. It's at a decimal, completely fine. negative 1.5, comma, negative 6.25. All right, from that information I pulled, I wrote it down. Negative 4, 0, 1, 0, negative 1.5 down 6.25, and it made a parabola. And it has a value of 1 in front, which means my slope is 1. Factor form, vertex form. Factored, I use my negative 4, 0, and 1, 0 to build. Opposite of minus 4 is plus 4. Opposite of plus 1 is minus 1. There's factored. Vertex was decimals. I'm going to substitute it in. Opposite of minus is a positive 1.5. Square the x, then the y value goes on the outside of the parentheses. X squared minus 4. When I graph x squared minus 4, I've entered it in. I check it crosses at negative 2 and positive 2. And 0 down 4. I've transitioned my graph onto my paper. When I do the vertex form, my vertex was at 0 down 4. For factored form, I'm going to use the intercepts, negative 2, 0, positive 2, 0, x plus 2, x minus 2. There's factored. X minus 9, x minus 8. I'm going to graph that. X minus 9, x minus 8. From the equation, hopefully you know it's going to cross at positive 9 and positive 8. The vertex, let's see, vertex is at 8.5, comma, negative 0.25, and it crosses at 8, 0, and 9, 0. So it doesn't even fit on my graph. So I'm going to use this data I pulled to fill in. Vertex form. My vertex was at 8.5, comma, negative 0.25. So I would do x minus 8.5 squared minus 0.25. For the standard form, I can either distribute my vertex or my factored. If I do factored form, I get x squared minus 8x minus 9x plus 72. x squared minus 17x plus 72 is my standard form. If I had distributed my values over here, I would have put x minus 8.5, x minus 8.5, minus 0.25. That makes an x squared minus 8.5x minus 8.5x plus, then I would do 8.5 times 8.5, 72.25, but because of my minus at the end, cancels out. And when I combine these two, 8 and 8 is 16, plus the 0.5s make it into a 17. So you have different ways you can find standard form. Last two questions are ACT questions. When 2x plus 4 squared is written in the form ax plus bx plus c, where a, b, and c are integers, what is the value of a plus b minus c? So I'm taking this and I'm going to write it twice because of the squared. You have never seen it with a number in front. This is new. 2 times 2, 4x squared. 2 times 4, 8x. 2 times 4, 8x. 4 times 4, 16. 8 plus 8, 16x plus 16. This is A, B, C. 4 plus 16 minus 16. Those cancel and you're left with 4. What is the area in square meters of the figure below? I have 9. This full distance is 11, 36. Okay, I'm going to break it up into different measurements. So let's see. If this is 11 and this is 6, that means this must be a 5 because 6 and 5 make 11. If this, yeah, that works. So the area of my rectangle would be 6 times 30, 6 times 30, and this one would be 5 times 9. And then I would just add them up. So that gives me 5 times 9 is 45. 6 times 3 is 18, put a 0. 225, 225. Meters squared if I want to make sure my measurement is accurate.